For as long as we have been human, we have looked up. We have gazed into the deep, dark velvet of the night sky, sprinkled with its countless points of light. We saw patterns in the stars, told stories about them, and used them to navigate our world. But beyond the myths and the constellations, a quiet question has always lingered in the human heart. It is a question whispered on the wind and reflected in our deepest thoughts. Are we alone? For millennia, this was a question reserved for philosophers and poets. The stars were simply distant fires, beautiful but unreachable. The idea that other worlds, like our own Earth, might circle those fires was little more than a dream. We live in a truly remarkable time. That age-old dream is now becoming a scientific reality. The quiet whispers of the past have grown into a chorus of discovery. We have begun to find that the universe is far more crowded, far more interesting than we ever dared to imagine. Those tiny specks of light are not just solitary stars, but many are the centers of their own families of planets. They are distant suns with their own collections of worlds, some small and rocky, others vast and gaseous. The night sky, once a canvas of distant, lonely stars, is now being revealed as a vast cosmic ocean, teeming with unseen islands. Each new discovery is a quiet revelation, a gentle reminder of the sheer scale and variety of creation. So what exactly are these new worlds we are finding? Scientists call them exoplanets. The term itself is quite simple. Exo is a prefix derived from Greek meaning outside or external. An exoplanet, therefore, is simply a planet that exists outside of our own solar system. For centuries, the only planets we knew were the ones in our own cosmic family: Mercury, Venus, Earth, Mars, and the giants beyond. They were our reference, our definition of what a planet could be. The discovery of exoplanets has shattered that limited view, opening our eyes to an incredible, almost unimaginable diversity. The significance of this discovery cannot be overstated. It represents a profound shift in our cosmic perspective. A change as fundamental as when we first understood that the Earth was not the center of the universe. Now we know for certain that planets are not a special feature of our Sun. They are, it seems, a common feature of stars throughout the galaxy. Planet formation is a natural, perhaps even inevitable, consequence of star formation. This simple fact reframes our place in the cosmos. Our solar system is not a unique jewel, but rather one of countless planetary systems in the Milky Way alone. This knowledge fundamentally changes our relationship with the universe. It brings a sense of connection to those distant stars. They are no longer just isolated points of light. They are potential homes for other worlds. The journey to finding these other worlds was long and patient. For decades, astronomers suspected they were out there, but proving their existence was an immense technical challenge. Imagine trying to spot a tiny, non-luminous moth flying around a brilliant searchlight from many miles away. That is the scale of the problem. A planet is incredibly small and faint compared to the blazing star it orbits. For a long time, our methods were simply not sensitive enough to detect such a subtle signal. The breakthrough arrived in 1995. Two Swiss astronomers, Michel Mayor and Didier Queloz, were studying a star called 51 Pegasi, a sun-like star about 50 light-years away from us. They were not looking for a planet directly. Instead, they were meticulously measuring the star's light, looking for a tiny, rhythmic wobble. Their patience was rewarded. They found that the star was indeed moving back and forth ever so slightly in a regular cycle of just over 4 days. This was the telltale sign of a massive unseen companion, gravitationally tugging on the star, pulling it one way and then the other. That companion was a planet, a world we now call 51 Pegasi b. The discovery of 51 Pegasi b sent a shockwave through the astronomical community. It was the first confirmed exoplanet to be found orbiting a star like our own Sun. And it was nothing like what we expected. This planet was a hot Jupiter, a gas giant about half the mass of our own Jupiter, but orbiting incredibly close to its star. It completes a full orbit in just 4 days, meaning its surface temperatures must be unimaginably high. Our theories of planet formation had suggested that giant planets should only form in the cold outer regions of a solar system, like Jupiter and Saturn. This discovery turned that idea on its head and opened the floodgates for a new era of exploration. As our catalogue of exoplanets has grown, we have come to appreciate the astonishing variety of worlds that exist. It is like discovering a whole new branch of biology, but for planets. We have found that nature is not limited to the blueprints we see in our own solar system. There are, of course, worlds that feel somewhat familiar. We have found rocky terrestrial planets similar in size to Earth or Mars, which we call Earth analogues if they orbit in the right place. We have also found giant planets, massive balls of gas and liquid like our own Jupiter and Saturn, often called gas giants. But the universe, it seems, has a much richer imagination. One of the most common types of planet we have found is a class that does not exist in our solar system at all. These are the super-Earths. As their name suggests, they are planets that are more massive than Earth, but lighter than the smaller gas giants like Neptune. They can be rocky, or they might be water worlds covered in deep global oceans. Alongside them we find mini-Neptunes, which are smaller than our own Neptune but still possess thick, dense atmospheres of hydrogen and helium. The sheer number of these intermediate-sized worlds suggests they may be the most common type of planet in the galaxy. A startling thought, given our own solar system lacks one. And then there are the truly exotic worlds, planets that push the boundaries of what we thought was possible. Scientists have theorized about and are now finding evidence for Hycean worlds. The name is a combination of hydrogen and ocean. These are hot, water-covered planets with vast, planet-wide oceans lurking beneath hydrogen-rich atmospheres. While their surface conditions may be extreme, some scientists believe that life could potentially exist in their deep oceans, protected from the pressures and temperatures at the surface. Beyond the standard categories, our telescopes have revealed worlds that belong in the realm of science fiction. These are the planets of extremes, places so alien and so bizarre that they challenge our very understanding of what a planet can be. Consider, for example, planets that orbit not one star but two. These are circumbinary planets, real-life versions of the fictional world Tatooine from Star Wars. From the surface of such a world, one would see two suns rising and setting in the sky, casting double shadows across an alien landscape. Other worlds are defined by their extreme chemistry and weather. There is a planet, a gas giant named HD 18973b, which appears as a beautiful deep cobalt blue from a distance. But this is no tranquil water world. Its color comes from a hazy atmosphere laced with silicate particles, the building blocks of glass. The winds on this planet howl at over 5,000 miles per hour, 7 times the speed of sound, whipping the glass particles sideways in a perpetual storm of horizontal rain. Elsewhere, deep inside the atmospheres of gas giants like Jupiter and Saturn, scientists believe the pressure is so immense that it could squeeze carbon atoms into solid diamonds, which would then rain down through the soupy skies. Perhaps the most lonely and mysterious worlds of all are the rogue planets. These are free-floating wanderers, planets that do not orbit any star. They were likely ejected from their home solar systems during chaotic periods of formation and now drift through the endless cold darkness of interstellar space. Without a star to warm them, their surfaces are frozen solid. Yet it is possible that some of these dark worlds, particularly large ones, could retain enough heat from their formation or from radioactive decay in their cores to maintain liquid water oceans beneath a thick crust of ice. They are galactic nomads, carrying the potential for hidden habitats through the void. Discovering these distant worlds is a masterpiece of scientific ingenuity. Since we can rarely see them directly, astronomers have become cosmic detectives, searching for the subtle clues these planets leave behind. One of the most successful techniques is known as the radial velocity method, or sometimes the wobble method. This was the technique used to find the very first exoplanet, 51 Pegasi b. As a planet orbits its star, its gravity gently tugs on the star, causing it to wobble back and forth. It is a tiny motion, but it affects the starlight we see. As the star moves towards us, its light is slightly compressed, shifting towards the blue end of the spectrum. As it moves away, the light is stretched, shifting towards the red. This rhythmic blue and red shift in the starlight is called a Doppler shift. By measuring it with incredible precision over time, astronomers can detect the wobble and infer the presence of an unseen planet. Another, even more prolific method is the transit method. This technique does not look for a star's wobble, but for a tiny dip in its brightness. If a planet's orbit happens to be aligned just right from our point of view, it will pass directly in front of its star, an event called a transit. As the planet crosses the face of its star, it blocks a minuscule fraction of the starlight, causing the star to dim ever so slightly. The beauty of the transit method is that it allows us not only to find a planet and measure its size, but also to study its atmosphere. When the planet passes in front of the star, a tiny amount of starlight filters through its atmospheric layers. By analyzing the starlight before, during, and after the transit, scientists can look for the chemical fingerprints of different gases, such as water vapor, methane, or carbon dioxide. This technique, called transit spectroscopy, is our most powerful tool for peering into the skies of these distant worlds. To hunt for these faint signals from distant worlds, we have built some of the most sophisticated instruments ever created. We have placed our eyes in space, high above the blurring effects of Earth's atmosphere, to achieve the clarity and stability needed for this delicate work. The true pioneer of the transit method was NASA's Kepler Space Telescope. Launched in 2009, Kepler was a revolutionary mission. For 4 years, it stared relentlessly at a single patch of the sky and the constellation Cygnus, monitoring the brightness of more than 150,000 stars simultaneously. Its goal was simple but audacious: to determine how common planets, and especially Earth-sized planets, are in our galaxy. Kepler was phenomenally successful. It changed the game from finding individual planets to performing a statistical census of them. It discovered thousands of confirmed exoplanets and thousands more candidates, revealing that planets are, in fact, more numerous than stars in our galaxy. Kepler showed us that small, rocky worlds are common. It found the remarkable TRAPPIST-1 system, a nearby star with no fewer than 7 Earth-sized, rocky planets. It also identified Kepler 186f, the first Earth-sized planet to be found orbiting within its star's habitable zone, the region where liquid water could potentially exist on the surface. Today, the search has been taken up by a new generation of observatories. The torch has been passed to instruments like the Transiting Exoplanet Survey Satellite, or TESS, which is scanning nearly the entire sky to find planets around the nearest and brightest stars. And the instrument we use for those studies is the magnificent James Webb Space Telescope. With its enormous golden mirror and its unparalleled sensitivity to infrared light, Webb is a master of analyzing the atmospheres of transiting exoplanets. It can detect the faint chemical signatures of molecules with breathtaking precision. Each new exoplanet we discover is like finding a new island in a previously uncharted ocean. These discoveries do more than just add to a scientific catalogue. They touch upon something deeply philosophical within us. They force us to confront our own cosmic context. For so long, we have seen ourselves as the center of the story, on the only special stage where the drama of life could unfold. The knowledge that there are billions, perhaps trillions, of other stages out there is a profound lesson in humility. Our Earth is not the center of the universe, and our solar system is not the only one of its kind. We are but one small part of an immense and varied cosmic tapestry. This realization does not diminish the value of our own world. On the contrary, it enhances it. In a universe filled with worlds of fire and ice, of crushing gravity and toxic air, our own planet, with its breathable atmosphere, its stable climate, and its magnificent abundance of life, appears all the more precious, all the more fragile. The search for other habitable worlds makes us appreciate the miracle of our own. The search for these worlds also has a wonderfully unifying effect on humanity. When we look up at the stars and contemplate the possibility of other planets and other life, our own terrestrial divisions and conflicts seem to fade into insignificance. This is a quest that belongs to all of us. And so the next time you look up at the night sky, take a moment, know that you are not just looking at distant points of light, you are looking at other suns. And around those suns are other worlds. There are hot Jupiters and super-Earths, water worlds and rogue planets, all drifting through the quiet darkness. We do not yet know if any of them harbor life, but we know they are there. They are our cosmic neighbors. And simply knowing that they exist, that the universe is so richly populated with other worlds, fills us with a sense of wonder and hope. The story of the universe is far grander than we ever knew, and we have only just begun to turn the first page.